The Charpy impact test. So this test measures the toughness of a material. Now we're gonna have basically our samples that in this case are kind of cubical or rectangular shape, and we put a notch there. The reason we put a notch there is basically it makes it easier to break. If there was no notch, it would take a lot of energy to break. So we're gonna put this sample into the machine, and the notch would be against the motion of the hammer. Okay, so
away from it.
Away from it, yeah. So you already been centered. Using this tongue is good because it's put the sample exactly in the center. Now we already have 406.75 joules of energy, stored energy, and the reason for that is basically the weight of the hammer, roughly 20 kilograms, the height is roughly 2 meters, and the gravitational acceleration is 9.81. So if you multiply all of them, which basically potential energy is mass multiplied by g multiplied by height, that gives you 406 joules of energy. So we already have that amount of energy stored. Once we release this hammer, right, it would basically hit the sample, and whatever energy is being absorbed by sample during the fracture, the rest of it would be recorded in here. So whatever ends up on this dial basically will be our impact energy. Okay, so in order to do that, we're gonna basically release the sample. I'm just gonna go back a little bit so we can see a better picture of it. Okay, ready? Go. Okay, so we're gonna stop the machine. The way to do it is basically there's a brake over there. There's a white button. If you just push the white button over there. Where? Next one. So stop the machine. Okay. So the sample is actually broken now, and usually they come out of the machine fairly. And as you can see, if you put them together, they already been bended and broken.
So it snapped quite a ways.
That's right. How much energy it took to break the sample? We go back to the machine, and roughly 100, maybe 190, maybe 189 joules of energy being consumed to break the sample. Okay, so we're gonna reload the machine again and repeat the test. So in order to reload the machine, we basically pull the hammer up, and then put the safety latch up, and we should be good to go.
The potential energy of 406.7 pounds or joules of force is what this machine stores. Now, as some of you might be questioning, if we have 190 left, isn't this the amount of energy that was stored, that was used up to break this piece? Actually, the way the mechanism inside this machine is set up is in reverse, so that it can measure the amount of energy used to break our piece. So, in case you're questioning, this is the amount of energy still remaining that can be used to break a piece. This was just a mild steel. We can also use hardened steels, stainless steels, that'll have different joules used to break them. So again, we're going to set the machine. We've got the arm set up. We're going to bring this back down, setting it to our 406.75. Now we're going to do a slow-mo, and we're going to see exactly what happens to the machine as it comes through to break this. We'll be able to measure